Completing square. What is completing the square? Okay, what's the meaning of completing square? So completing square is an alternative method to solving quadratic equations when the quadratic cannot be factorized. So if you remember what is the quadratic equations, okay, quadratic equations is by getting the points of x and y, okay, which is the maximum or the minimum points. So they had the form of ax squared plus bx plus c. So this where the points are maximum or minimum, okay. So in the completing square, if I can't factorize using the quadratic, I can use the completing square, okay. So most quadratic expressions can't be written like this. Completing the square fits the expression to the closest perfect square with an amount added or subtracted. Okay, so here we have a quadratic form that we can't factorize it using a quadratic, so we will use the completing square. So here we have x power 2 plus 4x plus 7. Okay, and we use here completing square. Okay, how to do or how to apply the completing square? First we have x squared plus 4x. I will bring a brackets like this and we remove the squared and we put the x as x power 1, which is x, plus then I will take only the coefficient of x divided by 2, so it will be 4 divided by 2, and then I will place the power 2 or the squared outside of the brackets here, and then I will put negative, and negative it's an obligatory step that I need to use it. Okay, here it's the negative, and then I will square the second number, so it will become 4 over 2 power 2, and then we'll place the 7 as it is. Okay, here it will be x plus 4 over 2 is 2 squared minus 4 over 2 is like a 2 but it's squared plus 7, and then x plus 2 squared minus 4 plus 7, which will give me this answer. So it's x plus 2 squared. Negative 4 plus 7 will give me just a 3. We will subtract here. So this is the final answer. So that's how we apply the completing square. Okay, so I need to clarify why we can't use the quadratic equations. So if we apply in the calculator here like this, so mod 5 the equation, and then 1 mod 5 3. So here we have x power 2 plus 4x plus 7. So the coefficient of x power 2 is 1 and the coefficient of x is 4, which is b, and the constant is 7. So when I click on equal, there is an I thing. I is the imaginary number, so this means that it can be solved by a quadratic equation. Okay, so that's why we used the completing square. Okay, let's try an example. Here we have a perfect square. Sorry, example number 1, perfect square. Complete the square for the expression. Okay, first I will draw a brackets and then we'll put the x just like x power 1 plus I will divide this coefficient of x by 2 will be 4, and then this power will be outside the brackets, and then I will put a minus or a negative, which is obligatory, and then I will power this number up, powered by 2. So 4 power 2 is 16 plus this 16, okay, equals 0. So the answer is x plus 4 squared equal 0. Okay. Okay, what is the turning coordinates? Okay, the turning coordinates is the maximum or minimum points that are in the curve. Okay, so we are answering the quadratic equation. So we have two options in the graphs. Either it looks like this, which is the minimum, or it can look like this, which is the maximum. Okay, here is the minimum point, and this is the maximum point. So the completing square allow me to get these points, the turning points. Okay, so it can get a minimum point or a maximum points. Okay, and we will see how to get the turning points in the upcoming example, like this. Here we have x power 2 minus 10x plus 17. So let's apply our rule. I will open the bracket, x minus, and then this 10 will be divided by 2, which is 5 squared, and then it's obligatory to put a negative, and then I will square the negative 5, be careful, negative 5 power 2, which will be 25 plus 17 equals 0. Okay, so after this, x minus 5 squared minus 25 plus 17, so we will subtract, so the answer will be 8 equals 0. This is the form of the completing square. Okay, well, how about we get the turning points? Okay, to get the turning points, we said we have two types of points, either minimum point or maximum point. Okay, how to get it? Okay, this point should be having x or y, so the number inside the brackets represents the x. So here I will be taking out the 5 as an x, but here it's a negative 5, so in the x I will take the opposite sign of the number. So if I have negative 5, so the x will be just a positive 5, because I'm taking the positive or the inverse sign of it. Okay, well, how about the y? Y we take it as it is, so we have here negative 8, so it will be remained as a negative 8. Okay, so this is the point where it's called turning points. Okay, let's dive into the next example. Here we have x squared plus 3x plus 4, so we will be applying the completing square, open the bracket, x plus this 3 will be divided by 2, which is 1.5 squared. Okay, and then it's obligatory to put a minus, and then I will power the 1.5 up by 2, which is 2.25 plus 4, which is equal to 0. Okay, we have here negative and positive, so we will subtract. Okay, so negative 2.5 plus 4, it will be 1.75. So x plus 1.5 squared plus 1.75. Then we'll take the coordinates if you need to find other turning points. Okay, so it will be, like I said before, that we will take the x in the inverse sign. So instead of 1.5, it will be negative 1.5, and then the y we will take it as it is, which is 1.75. Okay, if I need to know whether this point is maximum or minimum, okay, let's try to draw this. The negative 1.5 to be like here, and the 1.75 it will be here. 1.75 like this. Let's say this is 1.75, so the point is here. Okay, so this is a maximum point. Okay, because it's upwards, looking upwards, so this is the maximum points that we can get. Okay, and that's it for today. So if you have any questions, just send me a message, and we will continue in the next lesson. Goodbye.